Welcome to iTTV for Form 5 Chemistry. The title of this lesson, Comparing the Average Rate of Reaction. We already understand that the rate of reaction is how fast a reaction takes place. Today's lesson, we want to look at how to compare two different reactions so that we can understand which reaction has a higher rate of reaction and which reaction has a lower rate of reaction. Let's begin. First, we want to have a look at the reaction between hydrochloric acid and calcium carbonate. Method A. The time taken to produce 50 centimeter cube of carbon dioxide is taken for two experiments, A and B. The controlled variable is 50 centimeter cube of carbon dioxide. So what we're going to do is we're going to collect 50 centimeter cube for experiment A and then collect 50 centimeter cube for experiment B and basically record the time taken to collect the carbon dioxide in both the experiments. Our tabulation data will look something like this. For experiment A, the volume of gas produced was 50 centimeter cube. The time taken to collect 50 centimeter cube is 10 seconds. So, if we jump up to the board and quickly note this down for experiment A. So, let's note down what we know about experiment A. So, in experiment A, we collected 50 centimeter cube, so the volume of carbon dioxide was 50 centimeter cube. The time it took to collect the 50 centimeter cube was 10 seconds. So our time was 10 seconds. Now, we can calculate the rate of reaction for experiment A. To calculate the rate, remember what we do is we take the product or the reactant produced or used up and divide it by the time. In this case, we are looking at the product that was produced, which is the volume of carbon dioxide. So, our rate of reaction, we'll just write rate for short form. Our rate of reaction will be 50 divided by 10. What this gives us is a rate of reaction that is equal to 5 centimeter cube per second. So this is the values for experiment A. What about experiment B? If we go up here and list down the information for experiment B, the volume we produced was the same. Remember, this was the control variable. So we have 50 centimeter cube. But the time taken was different. According to our tabulation of data, the time taken was 25 seconds. So our time was 25 seconds. So if we were to calculate the rate, what we get is 50 divided by 25, which gives me a rate of reaction of 2 centimeter cube per second. So what we can say is in experiment A, the rate is higher than the rate in experiment B. So by comparing the values that we calculated, we can basically compare the rate of reaction for the two different reactions that we did. Both, remember, collecting 50 centimeter cube, but here what we're doing is we're collecting them at different rates. Here much faster, here slower. Let's go back to the tabulation of data. So if we look, the average rate of reaction for experiment A was 5 centimeter cube per second, and for experiment B it was 2 centimeter cube per second. So our conclusion, the rate of reaction for experiment A is higher than B. Let's have a look at another possible way of comparing the rate of reaction. Method B. The volume of carbon dioxide produced for two experiments, A and B, is measured after 20 seconds. Our controlled variable is the time, 20 seconds. The tabulation of data shows that in experiment A, the volume of gas produced was 40 centimeter cube. In experiment B, more gas was produced. In experiment B, we collected 80 centimeter cube of gas. Remember, the time taken for both experiment A and B was identical, 20 seconds. So to calculate the average rate for experiment A, we take the volume of gas produced and divide it by the time. So for experiment A, we get 40 divided by 20, which gives us 2 centimeter cube per second. In experiment B, we get 80 divided by 20, and the average rate of reaction is 4 centimeter cube per second. So if we compare the two, we can conclude that the rate of reaction for experiment B is higher than experiment A. So remember, when you're comparing rates of reaction, what you need to do is calculate the average rate of reaction and then basically say whether or not a reaction has a higher rate in comparison to the other reaction. Graphs for rate of reaction. Example: the reaction of 20 centimeter cube 1 mole per dm cube hydrochloric acid with excess calcium carbonate. The reaction equation will read CaCO3 plus 2HCl produces calcium chloride, CaCl2, plus water plus carbon dioxide gas. Now, what we can do is we can draw a graph for all of the reactants and the products. Remember, your reactants are going to decrease with time. Your products are going to increase with time. Let's start by having a look at the graphs that you could possibly get for the change in reactant and the change in product here on the board. So, when we look at graphs for reactants, remember the reactants are going to decrease in time. So let's put that down here. These are our reactants. And remember, the reactants are going to become less with time. So your typical graph for reactants should look something like this, a curve that's coming downwards. But if you look at the product, remember your product is going to increase with time. So if you do a graph of product, remember the product is going to increase with time, which means that we should get a graph that goes upwards like so. So always try to remember your reactants are decreasing and your products are going to increase. Let's go back to the slides and have a look at the different graphs we can get for the different reactants and products in the reaction between hydrochloric acid and calcium carbonate. So first, let's have a sketch of a graph for the concentration of hydrochloric acid against time. Remember, hydrochloric acid is a reactant, which means that it should diminish with time. So you get a graph where the curve goes down until all the hydrochloric acid has been used up. Now let's have a look at a graph for the calcium carbonate. Now remember, the calcium carbonate was in excess, which means that it will not completely finish. So the graph will look something like this. And right at the end of the graph, you still have some calcium carbonate left over because remember, it was in excess. Now, if we have a look at a graph for the concentration of calcium chloride, CaCl2, remember this is a product, so it should increase with time. Now, if we were to have a look at a graph for the volume of carbon dioxide, remember, carbon dioxide is also a product, so it should also increase with time. So try to remember the key things about the graphs. Remember that for your reactants, your graphs are going to decrease. Keep in mind that if you have an excess of something, it will not finish, which means that the curve should not reach the x-axis. It should be slightly above it because there will be some reactant left over at the end of the reaction. For your products will always reach a maximum value because the reaction has finished. So remember, your product curves are always going up. Explaining graphs. Steeper gradient means a higher rate of reaction. The gradient decreases with time because reactant is being used up. At the end, the gradient is 0. The reaction has stopped because one of the reactants has been used up. So here you got to be aware that sometimes in examinations, what we ask you to do is to explain a graph. That means you have to explain the 3 different areas of a graph. Let me explain what I mean by the 3 different areas of a graph. We'll use the graph of product at the back here to explain. So the 3 areas are, number 1, here, right at the beginning of the graph. Here, your rate is the highest. How do we know it's the highest? Because here your gradient is the steepest. Then, as your graph starts to curve, this is area 2 that you need to explain. Here your rate is slowing down. So here, rate is slowing. Why is the rate slowing? Well, because your reactants are being used up. So the concentration or mass of your reactants is beginning to become less. The final part is right at the end here. Here, your rate of reaction has finished. So your rate equals 0. The gradient is a horizontal line, which means that there is no reaction occurring. Why? Because either one or both of your reactants have been completely used up. Try to be aware here of which reactant is in excess. Just now, when we used the calcium carbonate and hydrochloric acid, remember the calcium carbonate was in excess. That means there was more. So the calcium carbonate was not used up. The other reactant, the hydrochloric acid, was used up. So be aware which of your reactants was used up. Because in the exam, you can't just say, oh, the reactant was used up. You must specify. That means tell me which reactant was used up. So be aware, the reactant that is excess will not be used up. The other reactant will be used up. So you can say here, the rate of reaction has become 0 because all the hydrochloric acid has been used up. Be aware of your reactants and how much you have of both of them. Let's go back to the slide. Graphs of rate of reaction. Rate of reaction at a given time. Instantaneous rate of reaction can be obtained from the gradient of the graph. Step 1. Draw the tangent at that particular time. Draw the right-angled triangle. Find the gradient. So sometimes in the examinations, you get a question where you are wanted to find the rate of reaction at a particular time. Normally in a reaction, we calculate or measure the product or the change in reactant every fixed time, 30 seconds, 60 seconds, 90 seconds, 120 seconds, or sometimes 1 minute, 2 minutes, 3 minutes. Occasionally, you're needed to find the rate of reaction at a time that is not one of the measured times. So, if we are calculating, say, the rate of or the volume produced at 60, 90, 120, I might say calculate the rate of reaction at 100 seconds. Here, you need to use the graph to be able to calculate that rate of reaction, which we call the instantaneous rate of reaction. Let me show you how to do it on the board. But first, we'll just clean the board. So first, let's draw the axis. Oops. So here is our time. And let's say that we are measuring the product, which is, let's say, volume of carbon dioxide, which will be in centimeter cube. And our time will be in seconds. So, what we're doing is we are drawing a graph of the amount of product being formed. So, we should get a line that goes up like this and then begins to curve and then finishes at the end. So, with the instantaneous rate of reaction, they might ask you to calculate the rate of reaction at a particular time. So, let's say they say, find the instantaneous rate of reaction at 100 seconds. Let's say that 100 seconds is here. What you need to do is plot a line up and find that mark here, like so, which means you need to find the rate of reaction at that point. Now you need to draw the tangent. Now, if you use your ruler in the exam, what you see is that this point here is a straight line. As you go up, the straight line starts to bend, which means that really your tangent needs to bend with it. You need to imagine that if the ruler was put here, it would be a straight line. So if you put your ruler here, as it bends, your ruler should be like so. So when you reach here, your ruler should be like this, showing that this line here is going straight. As you come further around, it bends a bit more, so your line should be going something like this. As you reach here, you should be going something like this. So you keep bending your ruler around. Imagine that this area here, the straight line should look something like this. Now, once you've worked out what your line should look like, draw a line like so. Once you've drawn this line, make sure that the triangle is not too big and stays within the boundaries of your values. Draw a right angle triangle like so. Once you've drawn your right angle triangle, you should have some values. You can find out the value here on your y-axis, and you can find out the value here, which is along your x-axis. Now you can calculate the instantaneous rate of reaction using a simple formula, which is y over x, like so. And then you will get the correct answer. Now, this takes practice because you need to be able to feel what the tangent is at that point. Remember, try to imagine the points just before and after your x and how a straight line would appear along that area. And then draw the line and then fill in or complete the right angle triangle, and then you should be able to find the rate of reaction. Let's go back to the slide. So what you should have is a graph that looks something like this. So like I said, try to imagine the straight line at that point. Then remember, the rate of reaction will be, as we say here in the slide, A over B or Y over X. Remember, your units depends on what you had along your axis. In this case, it will be centimeter cube per second. Let's try a question. 20 centimeter cube of 0.5 mole per dm cube hydrochloric acid reacted with excess magnesium to produce hydrogen gas. The following result was obtained. Now, from the tabulation of data, we want to draw a graph. We plot in our points for the graph and then draw in our curve. Now, from this, we can answer some of the questions that are asked. Firstly, calculate the average rate of reaction between 30 and 60 seconds. So, now that we've drawn a graph, we need to do some calculations. A. Calculate the average rate of reaction between 30 seconds and 60 seconds. So, the value at 60 seconds is 16 centimeter cube. The value at 30 seconds is 10 centimeter cube. So, 16 minus 10 divided by 60 minus 30 seconds gives us a value of 0.20 centimeter cube per second. B. The average rate of reaction during the second minute. Now, when they say the second minute, remember you need to take the value at 120 seconds and minus from the value at 60 seconds. So 28.8 minus 16 will give you a value that needs to be divided by 120 seconds minus 60 seconds. So what you get is a value of 0.20 centimeter cube per second. So remember that most of your calculations will come from the tabulation of data. But if they ask you for the rate of reaction at an odd number, like for instance 100 seconds, remember you've drawn your graph, so you should be able to draw the tangent and find the instantaneous rate of reaction. That's all the time we have for this lesson. Thank you for watching ITTV.